class, we discuss about the different definitions under the network topology. Under that, we discuss about what is tree, core tree, and what is node, loop, and then what is the branch, planar graph, oriented graph, like that. And then we discuss about what is tie set matrix and what is cut set matrix and what is the incidence matrix and what are the different network equilibrium equation in terms of the matrix form of the tie set and the cut set matrix. So in this class, I discuss about the what is duality. What is duality? So duality is nothing but the similarity. Simply it is called as a similarity. That means the two networks are said to be dual if any two networks are said to be dual networks of each other. That means if the mesh equations of a given network or the node equations of the other network or node equations of the other network. That means similarity conditions. That means if any two networks are said to be a dual network of each other, if the mesh equations of given network or the node equations of the other network. That means the duality networks was based upon the Kirchhoff's voltage law and Kirchhoff's current law. So dual means two circuits are said to be dual of each other if any two circuits are said to be dual of each other if the mesh equation characterized one of them has the same mathematical form as the nodal equation that characterizes the other. So the two circuits, when it will be considered as the dual, that means the similar, then the mesh equations, that is the loop equations of the given network, or the same, or whatever of one of the network has the same mathematical form as the nodal equation that the other network. So duality, this duality will be identical behavior patterns observed between voltage and currents between two independent circuits. The principle of the duality. That means if suppose that this duality of the network can be drawn for the AC or as well as a DC circuit, and it will be any resistance, inductance, whatever it may be there. So we will form in the one network, it will be in the form of the mesh. You have to be the other network can be characterized by the nodal analysis. So dual means it's said to be two circuits, it's said to be dual of each other. The mesh equations of one network has the same mathematical of the nodal equation of the other. So when you have to take a simple example, there is one resistor, one inductor and one capacitor must be there, and one voltage sources must be there. So when you have to apply the simple mesh equation, that means a loop, it is in the form of the series. So we have to consider the KVL, Kirchhoff's voltage law. So when you apply the Kirchhoff's voltage law to this network, so plus to minus. So we have to first we have to assume the polarities. So plus to minus, minus V. So algebraic sum of the voltages is equal to 0. No, plus to minus, minus IR plus L di by dt plus 1 by C integral of I dt is equal to 0. That is the, for the resistor, the voltage relationship is I into R. For inductor, the voltage relationship is L di by dt. For capacitance, the voltage relation 1 by C integral of I dt. So minus V plus IR plus L di by dt plus 1 by C integral of I dt is equal to 0. So V is equal to IR plus L di by dt plus 1 by C integral of I dt. So this is the actual network they have to given. So we have to convert this in the form of the dual means. So if whatever the voltage source must be there, so that means we have to convert these voltage source into current source. When this current source must be there, all are coming to the parallel form. So current source and there is resistors, inductor and capacitor are in series. So all are kept in the parallel form. So according to the current equation, so here this is the current source Vs, but it is Is, not Vs. So when the current source must be there, this current source will be parallel to the resistor, inductor and capacitor. So voltage source is converted to current source, resistor it is converted to the conductance. Reciprocal of resistance is conductance. Inductance is there, that is come to the capacitance. Capacitance is there, that is comes to the inductance. So when the circuit will be given in the form of the nodal, then all the sum of the currents entering is equal to sum of the currents leaving, or the algebraic sum of the currents is equal to 0. So minus I plus V into G plus C dV by dt plus 1 by L integral of y dt. So the current relationship of resistor is the, or that is equal to the I is equal to V by R. V by R. 1 by R is nothing but the conductance. So V into G, and L that is equal to 1 by L integral of V dt, and the capacitance it is C dV by dt. This is the current relationship. So we get I is equal to Vg plus C dV by dt plus 1 by L integral of V dt. That means when there is a voltage source must be there, you have to convert into the current source. So resistor, conductance, inductor, capacitance. KVL, when voltage is there, current source, current will be there, that is voltage. Resistance is there, we have to convert conductance. Conductance is there, it will be resistor. Inductor, capacitor, and capacitor behaves like inductor. KVL, KCL, and KCL it will be KVL. Voltage V of t and the current I of t. Either it will current I of t, it is V of t. Mesh analysis is there, you have to come nodal, and nodal is there, mesh. Series is there, it will be in the form of parallel. Parallel will be there, it will be series. V sin omega t, it is convert I cos omega t. Open circuit, then short circuit must be there. If short circuit is there, you have to convert it to open circuit. Thevenin's is there, it will be convert Norton's. Norton's is there, you have to convert Thevenin. Link is there, convert to twin. Twin is there, convert to link. Cut set, tie set. Tie set, cut set. Tree, core tree. Core tree, tree. Like that you have to be convert. So what is the procedure to have to obtain the dual network? First, place a node inside each mesh of the given network. These internal nodes corresponding to the independent nodes in a dual network. So first, how many how many loops must be there? For each network, you have to place one node. In the place one, inside one dot, one node must be there. Next, second step. Place a node and another node will be taken, that will be a reference node, that will be put in the outside of the network. So place a node outside the given network, the external node corresponding to the datum node in the dual network or difference node. Next, step 3. Connect all internal nodes in adjacent METs by dashed lines causing the common branches. Elements which are the duals of the common branches will form the branches connecting to the corresponding independent nodes in the node. So when you have to place the one node in each network, then you have to connect the one another node with the whatever the elements must be there. From the elements you have to connect at that node. Connected the internal nodes to the external nodes by dashed lines corresponding to all external branches. Dual of these external branches will form the branches connecting independent nodes on the datum node. That means if any resistor must be there, that one resistor will be connected to the first node and the second node, you have to connect them. If suppose the resistor does not connected to the second node, it only connected to first node only, then from that node it will be connected to the reference node, that is datum node. A clockwise current in a mesh corresponding to a positive polarity at the dual independent node. A voltage rise in the direction of a clockwise mesh current corresponding to the current flows towards the dual node. If the node which connected to the another node, that all are come in the form of the series. If one node will be connected to the another datum node or reference node, that will becomes to the parallel. So first we have to place the nodes inside each mesh of the given network, and like that place the another node of the outside of the network and connect the all the nodes, that is the adjacent to the elements, and the connect to the another node, that node will be only related to the that network, that will be connected to the reference node, and the whatever the series connections must be there, that are comes to the series, and whatever the parallel must be there, that are come into the parallel. If suppose there is voltage source must be there, it will be converted to the current source. Resistor, conductance, inductor, capacitance, inductor, like that the duality will be obtained. Say simple example, obtain the dual of the following circuit. Here there is voltage is there, resistor R1, two resistors must be there, that is R1 and R2, one inductance must be there, and one capacitor. So resistors comes to the conductors, inductor comes to the capacitance comes to the inductor, and voltage source comes to the. So first you have to observe how many networks must be there, how many loops must be there. So we put the dots of this loop. So here there is two loops must be there. You have to put one dot here and one dot to the second loop, and one reference that will be cut to the outside. So for the inductance L is related to both the nodes, so we put a dash line to both nodes. But the resistor will be related to only first node, and the voltage also related to only first node. So you have to connect the first node to reference node, and like that the capacitance and the R2 resistance also connected to the only second node, from second node to reference node. So how we have to draw means like this. So we have to put one node for the first loop, and second node for the second loop, and one reference will be 0. So for the inductor L, it is connected to both related to both first and second loop, so we have to put a dashed line. But this voltage source will be only related to the first, and like that this R1 also related to the first one, and R2 is also related to second, and capacitance C2 will be related to second. So we have to put 1, 1, 2 and 0. For 1, 2 the connection will be in the series, but here the inductor must be there, so you put the capacitor. And whatever the voltage source must be there, it related to 1 to 0, but the voltage source, it will be converted to the current source. If plus is forward, then it will be forward direction. If it will be reverse, then it will comes to rear. Same thing, the resistor also connected to first to 0. So 1 to 0, resistance comes to the conductance, and the capacitance also comes to the 2 to 0. For 2 to 0, the capacitance will be converted to the inductance. Like that the resistor R2 is come to the 2 to 0, the resistor will be converted to the conductance. Like that it will be converted to the network. And next, same thing, obtain the dual of the network. Here the current source must be there, resistor, capacitance, inductor, one inductor must be there, and two capacitors must be there, and two resistor must be there. So here you have to put 3 dots, 1, 2, 3 and one reference node. The resistor 1 to 2, the resistor will be connected, so it will be connected to the conductance, and 2 to 3 also there is inductance must be there, you have to convert it to the capacitance. Remaining C2, C4 and R5, C4 and R5 related to only third node, so it will be converted to conductance and inductance. C2 will be related to only second node, so it will be capacitance will be converted to inductance. The voltage source will be only first node, so first node to 0, so the current source will be converted to voltage source. Another example you have to take, obtain the dual of the following. So here also 3 nodes must be there. So in this 3, that means the and another one be 0 must be there. So 1, 2, 3. So 1, 2, 2 and 3. So for first node, second node and third node, the first node will be connected to only inductance will be connected only the first node. Like that, the second node only R1 voltage and R2 will be connected, and the third node there is only R5 will be connected. Remaining will be all comes to the series. So 1 to 2 there is R3 must be there, so we get the conductor G3. And 2 to 3. So 2 to 3 there is the this is the first, second and third. 2 to 3 there must be another must be there, that is what is that? That is the inductance must be there, that is capacitance must be there, you have to convert into inductance. Resistance, conductance. Conductance, when it will be the resistance part of you there is all converted into conductance. Capacitance will be connected to the inductance, and the current source will be voltage sources, and a series will be there, comes to the parallel. Whatever the parallel must be there, these are come to the series. These are come to the series. Same thing, obtain the dual of the network. Here also open circuit voltage source will be converted to the current source, and the resistance will be conductance, inductance, capacitance. Resistance will be conductance and the inductance will be capacitance. Capacitance will be inductance and the current source will be voltage source. Like that it will be converted. When there is the series form must be there, you have to convert the parallel. When there is a parallel must be there, you have to convert in the form of the series. Next one is, that means similarity of the network is nothing but the duality. Next one is nodal and mesh analysis. Already we discussed about this nodal and mesh analysis. Once again I recall that. So generally 2 power techniques in a circuit analysis, that is the nodal analysis and mesh analysis. Based on the systematic application of Kirchhoff's current law is nothing but the nodal analysis. Based on the systematic application of Kirchhoff's voltage law is nothing but the mesh analysis. KVL means the algebraic sum of the voltages is equal to 0, and KCL means the algebraic sum of the currents is equal to 0. So what is nodal analysis, and what is the procedure to have to write down this nodal analysis? First, identify how many nodes in the network and mark the values of each node. So ignore if voltage and currents are already marked. If it will be already marked, you have to ignore that. Just identify the nodes in the network and mark the voltage at each node. So first you have to identify the network and mark it at each node. Select a convenient reference node and ground it. Preferable, choose the node having the largest number of voltage sources connected as the reference node. At each node, write KCL equations assuming that node voltages is higher than the other node voltages in the circuit. Solve the KCL equation to evaluate unknown node voltages. So first we have to write down the how many nodes must be there. You have to assume the nodes, and then we have to write the KCL equation for each node. For related, that node will be related to which branches. So if you have find the current in all the resistor in the circuit given field. Node means 2 or more branches meet at one point is nothing but the node. So if I take node here, that is V, how you have to write down this? The algebraic sum of the currents is equal to 0. So that means a current I is equal to V by R. So V by R. So this related to this line will be related to 12 volts. So V minus 12 by 3, V minus 5 by 10, V minus 10 by 6 equal to 0. like that. So KCL note 1, V1 we have taken. So I have they have represent the current directions. No need to represent the current direction. Like simply we have to write. So I3, the sum of the currents entering is equal to sum of the currents will be leaving. So all are leaving to the node. So I3 plus I10 plus I6 equal to 0. So V1 minus 12 by 3 plus V1 minus 5 by 10 plus V1 minus 10 by 6 equal to 0. So solving V1 is equal to V1, you get the common, then you get 10.28 volts. So that's how you find out the currents. When you have to find out the I3 current, then V1 minus 12 by 3. So V1 value we already know, that is 10.28 minus 12 by 3. It is minus 0.573. Like that 10.28 minus 5 by 10, that is 0.528. Next 10.28 minus 10 by 6, that is 0.046667. Like that you have to solve the currents. And what is the supernode analysis? Supernode analysis means if a network has a voltage source such that none of its terminal is directly connected to the reference or ground node, then the difficult to write KCL equation at the node to which the voltage source is connected. To overcome this difficult supernode technique is made. In this technique, so these two nodes are connected by voltage source or reduced to a single node called as supernodes. That means if you observe this, there is only one voltage source is connected between the two nodes. That type of network is called as supernode analysis. So when there is only voltage source will be connected to the two nodes, that means if there is one resistor must be there, it is not will be a supernode. When there is in between the two nodes, there is only one voltage source will be connected, that will be called as supernode. So at the time of the supernode, how we have to be calculated? That means, so we have taken a simple example here. When you observe that these two volts will be connected between 1 and 2 nodes, then how you have to calculate? So when wherever the that voltage source must be there, you have to write that equation in the separate form, and you have to eliminate that part and write the different equation. Then how it will be, we have observed. So first node 1. So here there is V1 and V2 must be there, that is whatever there, this is the I10 and I2 and I4 must be there. So how you have to write? 2 is equal to, why I am taking the 2 means it is the entering to the current and it is the leaving to the current. These two are current sources. So there is no need to write in the form of the voltage. So there is directly the current source must be there. 2 is equal to V1 by 2 plus V1 minus V2 by 10 plus V2 by 4 plus 7. So 12 V1 plus 3 V2 is equal to 100. So KCL corresponding, when there is the supernode must be there, you have to write down the equation in the that form. That is V2, it is in the plus 1. So V2 minus V1 by 2. So on solving these two equations, we get the value V1 is equal to 7 minus 7.00066 volts and V2 is equal to minus 5.066 volts. 5.066 volts. Like that you get the total equations. Whenever there is the supernode must be there. So by lefting that supernode, you have to consider the total equation in the one form and that supernode equation in the is the other equation, and solve these two equations, you get the total what is the voltages obtained in the circuits. Whenever you know the voltages, automatically you have find out the current in the each element. So like that, the another problem is there here also. In V1, V3 there is one 2-volt source must be there. You have to eliminate that two. You have to write down the equation of 2-volt source for that equation, and you have to eliminate, and you have to consider the total equation will be one form, and then you have to find out. Then you get the value. V1 is 17.667 and V3 is 15.667. Next, what is mesh analysis? Mesh analysis means here convert all the current sources, if any, into the voltage sources using the source transformation technique. If say any current source must be there, first you have to convert that current source in the form of voltage source, because the algebraic sum of the voltages is equal to 0. That is called as mesh analysis. Identify the meshes, identify the meshes in the circuit and assign current directions. Assign current direction in each mesh. First you have to identify the meshes in the circuit and how many loops must be there, there in the circuit you have to identify. Next, mark the voltage polarities across each element of the circuit, either positive sign at the end where current enters and negative. For each element you have to mention that if it will be entering to the entering of the current direction, then we put it as positive. If it will be the leaving, put it will be negative, and write the KVL equation of the each loop. So how it will be positive. So simple circuit must be there. So you have to assume that 2 loops must be there. So when the current will be entering, no need to assume the polarities of the voltage sources, because already it will be polarities must be there. So if the current, if I take the direction entering plus in the 10, entering will be plus, leaving will be minus, entering will be plus, leaving will be minus. Like that you have to assume the sign. So entering plus, leaving minus, entering plus, leaving minus, entering plus, leaving minus. Like that you have assumed all the signs, and you have to write down the equation. Sum of the current entering is the algebraic sum of the voltages is equal to 0. So plus minus 2 plus, so plus 50, plus 2 minus minus 10 I1, plus 2 minus minus 3 I1, and plus 2 minus minus 5 into I1 minus I2. Why I am taking I1 minus I2 means these 5 ohms will be related to both I1 node and I2 node. If the direction, if I take the first loop, I take the first loop current is the polarity is preference. If I take write down the second loop, the polarity will prefers to the second loop current. So if it will be the 2 loops must be the 5 into I1 minus I2. If the same direction must be there, then it will be I1 plus I2. If it will be opposite direction must be there. Here we observe that one is the positive direction and one is the negative direction. So I am telling that I1 minus I2. So minus 50 plus 10 I1 plus 3 I1 minus 5 into I1 minus I2 equal to 0. So first equation is 18 I1 minus 5 I2 equal to 15. Like that, second also minus 5 I1 plus 6 I2 is equal to minus 10. So when you have to solve these two equations, you get I1 is equal to 3.012 amps and I2 equal to 0.843 amps. Next. So another one example you have take, and if you observe here, there is a current source must be there. So same one, but you have to convert these current source in the form of the voltage source. That is 5 amps and 10 ohms are in parallel. So you have to convert into the voltage source. We get V is equal to I into R. V is I is 5 and R is 10. 5 into 10, 50. This 50 voltage source is series with the 10 ohms. Then it comes to the one loop. Then you have to find out. Next one is super mesh analysis. In the super node analysis, if the two nodes there is one voltage source must be there, then it will be considered as super node analysis. Super mesh analysis means if any path, any loop, there is the current source must be there. If two loops there is any current source must be there, then it is considered as super node analysis. Because when you observe here, In the first there is V1 and second also V2, but in the middle point there is a current source must be there. That means without the element there is the source must be there and that path. Then it is considered as super mesh analysis. So how you have to consider? So when you observe here, there is two loops must be there, but in this the third middle point of view there is the current source must be there. So when there is the current source must be there, you have to write that equation in the separate and you have to consider the total equation will be one loop. Okay, how you have to write? So when there is super node, that is minus 20 plus 3i1 plus 2i2 plus 4 equal to 0. 3i1 plus 2i2 equal to 16. And second one, this. So total I1 and I2 will be considered as total one loop only. And whatever the current source must be there, you have to consider the another loop. I2 minus I1 is equal to 3 amps, because these 3 amps will be related to both I1 and I2. Depend upon the direction you have to consider. So I2 will be same direction, I1 will be opposite direction. So I2 minus I1 is equal to 3 amps. So when you have to solve these two equations, you get I1 is equal to minus 4.4 amps and I2 equal to minus 1.4 amps. So when there is any current source between the path, you have to consider it the super mesh. When there is any voltage source between the path, then you have to consider super node. So, and there is another example, solve it. Here also the 7 amps will be connected to the I1, I2, another loop must be there, that is I3. Then you have to solve this equation. So there is the two loops, three equations must be there. This is considered the one equation, and I1, I3 must be considered the one equation, and you have to solve these currents. So I1 is 9 amps and I2 is 2.5 amps and I3 is 2 amps. So in this class we discuss about the what is a dual network and what is the mesh analysis and nodal analysis and super mesh and super node. Thank you.